So now this is the second part of this chapter. It's inverse of a function. What does mean inverse of a function? How we're gonna calculate it and how we're gonna graph it? And does an inverse of a function exist all the time, or there is some conditions? We will see in this video. First, when I say inverse of a function g of x, its notation is g minus 1. It means I'm walking inversely. What does mean I'm walking inversely? If g of x is from a to b, if a represents the domain of g and b represents the range of g minus 1 of x, it means I'm going backward. So the range of g becomes the domain of g minus 1 and the domain becomes the range. So I'm going this way. So example, I want you to know how to find the values of g minus 1 from a table. So if I have this table where I have some particular points, if I ask you to find g of 1, so you look where for x is equal to 1, what is g of x? So it's 2. But if the question was to find g minus 1 of 0, it means what is the values, this one means what is the values of x that gives me y 0. So I look at where is y, this is y here, this is g of x 0, so g minus 1 of 0 is 4. So I'm going backward. This is how do we read the value of the inverse function when I have a particular point on a table. Now how are we going to calculate algebraically, and can I calculate it all the time? Let's see in the next example. Now example 2, I need to calculate the inverse of f of x, and we're gonna see how we'll find the domain and the range. If f of x is given 1 over x minus 2 plus 3, first of all, the domain of this function is what? It's minus infinity 2 unit 2 plus infinity. Why? Again, I'm reviewing that. We have a fraction. A fraction is defined when my denominator is not equal to 0. This domain that I have here will be later on the range of f minus 1. And when I will find f minus 1 of x, the domain of f minus 1 of x will be the range of f of x. How we'll see how. First of all, to find the inverse function, all what you need to do is we need to switch x by y and y by x. You can do this switching step or in the beginning or in the end. Yani, what does it mean? You can solve for x and then in the end switch, or you can switch here y by x and x1 by y. And my objective now is to find what is the value of y. Sure, you can do the same denominator, you cross multiply, and then you can do many steps to do this calculation. But here I saw it's easier for me. So I take 3 to the other side. So I will have 1 over 1 y minus 2 is equal x minus 3. Now, 1 over y minus 2, it's inverse. Y minus 2 is equal 1 over x minus 3, or even you can cross multiply and then solve for y. It's your choice. Now I got y minus 2 is equal 1 over x minus 3. It means y is equal 1 over x minus 3 plus 2. I can do here the same denominator. By multiplying 2 by x minus 3, I will have 2x minus 5 over x minus 3. So this function here is f of minus 1 of x. What is the domain of f minus 1 of x? It's x not equal to 3. It means it's minus infinity 3 union 3 plus infinity. Excellent. So the domain of f is minus 2 minus infinity 2 union 2 plus infinity. And the domain of f minus 1 is minus infinity 3 union 3 plus infinity. So now I can deduce what is the range of f. Sorry, the range of um, f is the domain of f minus 1. So the range is the one of this one. So what is the range? The range is the domain of, so I can write here the range. I think I wrote it, the notation just. What will be the range? So this domain here represents the range of, no, I wrote it properly, of f minus 1. And this domain here represents what? The range of f. So what's gonna be? This is the domain of f, this is the range of f here. And here, this is the domain of, now this is the domain of f, this is the range of f. This is the domain of f minus 1, this is the range of f minus 1. So we can switch it, guys, as we said. So if I write here, for example, minus infinity 2 union 2 plus infinity, this is the domain of f. What's going to be the range if I go right like this here? The range will be minus infinity 3 union 3 plus infinity. And if I go this way, now it's more clear. So this is the domain of f minus 1. This is the range of f minus 1. Now let's go to another example. And before I will need to write a remark, and then we move to the last example. All the functions have inverse. We will see that not all the functions that have inverse functions. Only functions that are one-to-one and onto functions have inverse function. Let's review what does mean one-to-one. It means that when I say one-to-one, it means I don't have a repetitive y. We can say it indirect in another way. We say monotonous, strictly monotonous. It means when the function is strictly increasing or decreasing. Look at the graph here. When the function is strictly increasing, like this one here, if you do the horizontal line test, it cuts on one point. It means I don't have a repetitive y. It means it's one-to-one function. So a strictly monotonous function has an inverse, and it should be also not just strictly monotonous, continuous. What does mean continuous? Onto. What does mean onto? It means no y that doesn't have an x. I don't have any y that doesn't have an x. So every function that is one-to-one and onto function has an inverse function. If it's not this case, it doesn't have an inverse function. Or also we say every continuous function, it means the function should be continuous. I cannot have a discontinuity. Or and strictly monotonous, it should be continuous and monotonous. It means it should be continuous and increasing or continuous and decreasing to say that this function admits an inverse function. With this example that I will do now, you will understand more what I mean by strictly increasing or strictly monotonous or strictly decreasing. Okay, so now after or before I move to the example, when the inverse function exists, how are we going to graph it? To graph it, I do the symmetry with respect to y equal to x. Also, we'll do it in this example. Let's move to the last example that's very, very, very important, and it will summarize all what I was talking about. So we have the function y is equal x squared plus 1. So I need to find the inverse relation of y equal x squared plus 1. Why they said here inverse relation? Because I could have, hello, we'll see why they said relation. Then graph it both and state two different domain and ranges in order that its inverse is a function. So it means that there is something wrong here with the inverse. So I have two domains and two ranges. Let's see what I mean by that. If I take the function y is equal x squared plus 1, excellent. We said that if I want to find the inverse, I need to switch. Excellent, I will switch. X is equal y squared plus 1. Okay, I'm going to solve for y. I will have y squared equal x minus 1. Excellent. Y squared, I need to square both sides, square root both sides to have y. If I square root both sides, what is square root of y squared? We know very well that I don't know what is the proper sign of y. I'm not sure if y is positive or negative. So what is square root of a squared number? Its absolute value of y is equal radical x minus 1. And we know very well that absolute value of any number, it gives me or the same number that's inside if my number is positive. So if this is positive, so absolute value of y gives me y. But if this is negative, absolute value of y gonna give me minus y. And in this case, y will be minus radical x minus 1. So you look here, guys, I don't have one inverse function. I have two inverse functions. That's why they mentioned that we need they mentioned here that you need to change the domain and the range or the restrict the domain and the range to have the inverse as a function. Because if you write here plus or minus radical x minus 1, it means that it's a relation, it's not a function. We will see also why we say it's a relation, it's not a function. So here I need to divide it into parts. I need to mention that when y is positive, so when y is positive, what's gonna be x here? X bigger or equal than 1. I'm talking this is the range of the inverse and this is the domain of the inverse. So the domain of inverse is gonna be the range of the function f, and here also the same. When y is negative, x is bigger or equal than 1. So how are we gonna write that? Let's go back here. Let's continue now here. So it means I have two inverse functions, this one and this one. But I need to state the domain of the function and its range and the domain of the inverse and its range. So as I said here, we said that for y bigger or equal than 0, this is the range of f minus 1. It means this is going to be the domain of f. So for x bigger or equal than 0, y is bigger or equal than 1. So the domain of the function for x bigger or equal than 0, the range will be bigger or equal than 1. And the inverse function will have, this is its domain, this is its range. We switch it. And the inverse function will be y equal radical x minus 1. Guys, you will see that in the graph now. Now, if, second case, if I'm in this case now, when y is negative, it means this is the range of f minus 1, so it's going to be the domain of f of x. And if for x less than or equal to 0, what's going to be the inverse function? This is the inverse function. And what is its range, bigger or equal than 1? So for x less than or equal to 0, this is the domain, this is my range here. The inverse function will be minus radical x minus. So here I have two inverse functions. For x positive, it gives me an inverse function, and for x negative, it will give me another inverse function minus radical x minus 1. Let's look at the graph and see if all what I wrote here is right or wrong. So if I go now to graph the basic function radical, x squared plus 1, it's a quadratic. That's it. It's a quadratic function. It is continuous. It means it is an onto function. Yeah. Is it a one-to-one function? It's not a one-to-one function. If you go to the horizontal line test, it cuts in more than 1 point. So it's not an onto function. So I need to divide it in two parts where it's onto function. So that's why they said for x positive and x negative. Look, when x is negative, here it's x negative or equal to 0, it is an onto function. And one-to-one. It's one-to-one. That's it. So, and also I said in the different language, it's strictly monotonous. It's decreasing. So this part admits an inverse function. And the inverse function, we're going to draw it now. We said we will draw it symmetry with respect to y equal to x. So I'm going to draw y equal to x. How we draw y equal to x? We call it the first axis of symmetry for x1, y1, for x0, y0. So that's it. This is y equal to x. So now I'm gonna draw the inverse function of the first part. So this one is for x negative, this one of the part of x squared plus 1, and the inverse is a radical, and you know that the radical has this shape. So it's gonna be like this. So let's do the inverse function. How are we gonna do it? So I will use the same color. So symmetry. So this point I will do perpendicular as it is. It's gonna become here. Okay. Now this point, where this point gonna be? This point gonna be here. So I will continue doing that so that I will have the first part of this one. And if you look here for x negative, it's minus, so it's gonna be under. So it's here. And then I continue. This one is approximately here. And then I did this right. Yeah, like this. And then I do the first part of it. So it's gonna be like this here. Okay. So this one, its image is here. Now let's do this part. When I said, and this one is the radical function, yes, because it's minus, so it's gonna go downward, so it's right. This part here, where is its inverse? So this point is still here. This point here is gonna be here. This point is gonna be here, and then it's like this, and then it will be like this. And look at this, guys. This yellow part, its inverse is this yellow part. The purple, it's a purple, and you can see, guys, that this part, it's a radical, yes, and this one also, it's a radical function. So, and if I look at the range, yes, here the range is bigger or equal than 1, as I said. And here, if I look at the range, here it's y is positive, and here y is negative, as also we said in the exercise. So that's it. So every time I need to do the inverse of any function, the function should be one-to-one and onto. What does it mean, one-to-one? It means continuous. So that is all the values I have an image. And when I say one-to-one, it means I don't have a repetitive y. It means it should be strictly or decreasing or increasing. Look at the purple part, strictly decreasing. So it has an inverse function. This is the inverse function. And look at this one, it's strictly increasing. And this is its inverse function, strictly increasing. That's it. Sure, as I said, we will do more application in the class. So don't forget, guys, to like, subscribe, and share. And we'll see you next time in the other